Okay, so let's talk about some more cell phone DC electronics. This time, we're going to talk about capacitors and inductors. The symbols on the schematic on the page, the left one is a capacitor, and the right one is an inductor. So what is a capacitor? A capacitor essentially is two plates that have space between them. And if you put enough voltage or current through them, they pass their electrons through those two plates, despite the gap between those two plates. So you're essentially forcing those electrons to travel over a non-conductive distance. And if you're to think about this like as an analogy, it would be like Dukes of Hazzard. You know, just jumping the general over a bridge, right? And essentially, you know, they got to jump the car over a bridge and they got to build up enough speed. And the only way to make it to the other side is to build up enough energy to make that jump. I meant the General Lee. But anyway, to jump the General Lee over the bridge, you gotta have built up enough energy. And that's what a capacitor does. You build up enough energy and essentially electrons will travel from one plate to the other. So for a capacitor, what you're doing is you're essentially storing a charge. And in essence, going back to that same example of the sports arena, sports complex, you're storing that energy, and all of the energy is really, really compacted on one side. And the gate only allows one person at a time. And so what the capacitor does is it really, really organizes the energy flowing through it to the point that it's very rigid. And so a capacitor is great for filtering a line and potentially storing energy in order for that line to be able to trickle through in a rigid sense. So what a capacitor does is it acts like kind of like a water tower in the sense that if you turn on the kitchen faucet, you want a steady flow of water. You don't want a flow of water that's spurting out like Morse code. You want something that's steady. And so the capacitor acts as that tank of energy to give that steady flow of electricity through it, making it less of a sullied mess that electricity is. Electricity is very messy. It's dirty. It's they call it like dirty voltage, right? You got a lot of ups and downs. If you were to measure voltage in its in its natural state, you would be measuring a number that goes up and down. And you might have 1 volt, but all the decimal numbers on that right side will bump around. But if you put it through a capacitor, that capacitor will make a more consistent number. And so that's what's great about capacitors, is that they kind of they organize the flow of electricity. And then you have inductors. And inductors are essentially a coil of wire. And all they do is they're coiled together and they create a magnetic field. And that magnetic field also stores energy. And so essentially, you think of like a magnet as like an earth magnet that you would have like on your fridge. That's always magnetized. It's always on. It always has 1 pole and another pole, a negative and a positive, and they're attracted to each other. An inductor does that, but it's a temporary. And it also filters a line. So again, it creates a stable amount of electricity, but it uses magnetism to do it. It uses an electromagnetic field. And so for capacitors, it stores its energy in an electrical field, and inductors store their energy in an electromagnetic field. So capacitors tend to be more voltage centric, and inductors are more current centric. Capacitors tend to oppose a change in voltage, and inductors tend to oppose a change in current.